Hello everyone, welcome back to Beauty and Simulations. I am Lakshman Anumolu. In the previous videos, we have configured our systems with required utilities. In this video, I will present the overview of the workflow and review the required steps to prepare and render a scene from CFD results. We have installed Git for version control. And to use the rendering application, we relied on cross-platform containerization tools, Docker and Singularity. For this tutorial, Git will be used to manage scene templates repository that contains sample scene files. In this video, we will go through basic Git commands that can help to accomplish tasks such as cloning a repository, updating the repository, pushing some changes, and raising a pull request so that you can make your templates available as part of this repo. For systems with Linux and Mac, we have the options of using Docker or Singularity. In this tutorial, I will be using Singularity to run rendering application, because it does not require the user to have elevated privileges, so it will be convenient to use Singularity both on the local and on the remote systems. For example, system administrators of universities or companies clusters will feel a lot more comfortable for you to use Singularity over Docker. If you are a Windows user, you can do everything that we are going to learn in this tutorial by running a rendering application on Docker. The workflow that we will be using in this tutorial is we will first clone scene templates repository from GitHub, which we already did in previous videos while setting up the environment. Next, we will be preparing a scene file by using existing ones as templates. After we prepare a scene file that contains results from CFD simulations, we will use Singularity to render the scene by using Mitsuba renderer. Finally, we obtain a photorealistically rendered image. We will see our workflow with an example. The steps we are going to see here are the same for both Linux and Mac. The only exception is, while working with Mac, you need to make sure Docker Desktop is running. First, clone the scene templates repository from GitHub and place it wherever you like. I already cloned it and placed it in this location, but let me clone it again into a different location just to show the command in action. That's it. All the scene files are under Mitsuba renderer directory. After cloning this repository, before starting to render, place all the surface files into a folder with name surfaces. Let me delete this one because for this demo I have created one. Let me move that here. I have also prepared a scene file that renders a glass box. Let me copy that into the Mitsuba renderer directory. Now we have a scene file and a folder that has surfaces. We need two more files for our workflow. The render script that calls Mitsuba to render the scene and the run Singularity script that runs this render script. Let's prepare render script, for which I will make a copy of renderstudio.sh file. Let me make a copy of this and rename this with render demo. We need to make few changes to this file. Let me save images to a folder called images demo, and I will increase this to 14 so that I'll be using 14 process while rendering a scene, and this everything looks good. Let me rename the output image to demo. Scene file is demo.xml. Let's save this and close this file. This script and the scene file is currently written to only prepare one image with one object, but we generally want to render many objects or surfaces to produce hundreds of images in order to make an animation. We will see this in the upcoming videos. Now that we have render script ready, the only remaining thing is to update run Singularity. In this file, all we have to do is to call render demo. Let's go through everything once again. We have surfaces folder, we have a scene file, and we prepared a render script to call Mitsuba with this scene file, and finally we have a script that runs Singularity command on our render demo script. Let's run the run Singularity script now. I am in Mitsuba renderer directory. Let me run the script. And here is the output. In case you want to use Docker, all we have to do is to rename our render demo file. Let's do that. I do have a render.sh script. I'm going to delete this. All I have to do is I have to rename render demo.sh with render.sh. This is because our Docker image by default calls render.sh and it only calls that. Before we run Docker, let's remove this output directory and now let's run Docker. And here is our output. If you are a Windows user, all the steps we have discussed so far holds. That is, we have to clone the scene templates repository and then get the surfaces folder, prepare render script, and finally call the script with Docker. Let's do step by step. First, clone the repository. After cloning the repository, let's go inside Mitsubah render directory. Move the surfaces folder into this directory. Next, we have to prepare a scene file. I already did that, so let me copy that here. After preparing a scene file, we have to call this in render.sh script. In render.sh, we have to call demo.xml. I will use output image name as demo.png and I will change this to 14. I will use images demo as the folder name. Here we have surfaces folder. We prepared a scene file. We prepared this render script. Finally, all we have to do is to execute Docker command. But before that, we have to edit line endings of this file, of this render.sh script. Let's do that using Notepad++, which is what I already have opened. Let's go to UL conversion. I'll use Unix option and save this file. Now we have everything ready. We have to execute Docker command. Before we execute Docker, we have to make sure Docker desktop is running. Search for Docker desktop and start that. I already have that running. Before I execute the Docker command, I want to see the images. I already have the Mitsubah render image available, which we already did in one of our earlier videos where we did our environment setup. Let's do a quick recap. This says that we are creating a Docker container, which is a temporary one. It will be removed after the task is completed. This says we are binding the current volume to this directory inside the Docker image. And finally, this is the Docker image. Let's run this. And we have the image. We went through a quick overview of the workflow that we will be using in this tutorial, and you may also be using this to render your CFD results soon. Before we jump into our first video to prepare a scene, let me present a few Git commands that you can use to contribute your scene files to this repository, so that your settings can help other researchers to realistically render their CFD results. The exercise we are going to do is for users who are new to Git. For others, it will look too basic as I am going to cover only a few commands. This is by no means qualifies as an introductory tutorial for Git, but it will get our job done. If you are interested to know more about it, there are many tutorials out there. I would recommend Pro Git book, which you can read for free here. URL is provided in the description of this video. Let's do a little exercise now using the same workflow that we saw earlier. By logging in as another GitHub user, I am going to demonstrate how to submit patches. This is one of many ways. There are many other approaches that developers follow. Please feel free to submit your patches by any means you are comfortable with. Let's get started with this little demo. I am acting as a contributor here. I am going to show this demo using my wife's account. First, we have to fork this repository. After the repository is being forked, we have to clone this repository. We can copy this link and clone it. Next, create and check out a different branch. As a contributor for this demo, I will make some minor additions to the README file. After making changes to the repository, we have to commit these. We can get an overview of the changes by using git status command. This is the file that I have changed. While making a commit, I first add it and then commit it. You may use any other procedure that you are used to. Let me add it so the changes have been staged, and now I'm going to commit it. Once the changes have been committed, you have to push this branch, which can be done using git push origin. Now we can go to our GitHub account. Let me refresh this page. We can see update readme. This is the branch that I have pushed just now. Let's click on this branch and we can see this new pull request button. Let me click on that. Here it is going to create a pull request, which creates a patch based on my changes to the local branch to the parent repository. Click this create pull request button. That is all. Now I switched back to my account. I have a new pull request. I will be going there to review and approve it. Once the pull request has been merged, you can update your local master repository. Let's look at that. At this point, I know that my contributed changes have been merged into the original repository that I forked from. Before I pull those changes, let me add that master repository here. My local repository is currently tracking one remote repository, which is my repository as a contributor. Here, before I pull the changes that were merged into master branch of the original repository, I have to add that repository here. Let me add that using git remote command. Using this command, we now have an alias upstream that points to the original repository. Now my local repository is tracking two remote repositories. I now have to fetch updates from upstream's master branch. I'll be doing that using git fetch. I have to check out to master branch now. This is the local master branch. Now that I already have fetched the changes from upstream's master branch, I now have to merge those changes into my local master branch, which is done using git merge command. At this point, my local master branch is up to date with upstream's master branch, whereas upstream is pointing to the original repository. But the master branch on my account on GitHub is not up to date yet. In order to update that, I have to push these changes, which can be done using git push origin master. This pushes changes from master branch in the local repository to origin, which is my forked repository. That is all. We are done here. You need not follow the steps I mentioned here. Please feel free to follow an approach that you are familiar with. We will see one final scenario where you want to act as a user of this repository but not as a developer, for which you need not do any of these steps. You can clone directly from this repo and keep your local repository up to date. Let me also show that quickly. I am a user now. All I have to do is to clone the repository using this command. After cloning this repository, whenever I want to update it, I just need to run git pull command. Like this. This command will update my local master branch with the changes from this remote repository. This is the brief overview of a few basic commands and workflow we are going to follow in this tutorial. I hope you will enjoy and learn a few things in the next set of videos. Here are my contact details. Please feel free to ask any queries related to this video or drop a line with some feedback. Thank you for watching. Please subscribe. See you in the next video.